Hi guys, in this video we are going to take a look at setting up limits over cylindrical coordinates over each solid. Alright, so the first one is the cylinder, and how we know it's a cylinder is because we have a missing variable, right? So x and y are there, but z is not. So if you look at it, x squared plus y squared equals 16 is just a circle with radius 4. But if you like go into the third dimension, then z could be anything and you get yourself a cylinder where z is any number. But here it's between z equals -6 and z equals +2. So generally the way we set up three-dimensional coordinates is we're going to have the inside integral is going to be from the bottom surface to the top surface. But here it's just -6 and 2. So if you look at the picture over here that I have, so this is the cylinder, right? So this is the x squared plus y squared equals 16, which is a circle of radius 4. But you basically move the circle along the z-axis, and the bottom clip is -6, the bottom surface, and the top surface is z equals 2. Those are like just the parallel to the xy plane. All right, so there is your cylinder. So for z, we'll just go from -6 to 2. How are we going to go for r? So r is going to be the same as you do for polar coordinates. So if you're trying to set up your limits over this circle of radius 4, so you can see the circle right here. So you fix the theta. Okay, and let's just imagine that this is your theta. Okay, this is an angle theta that's fixed, and your r is going to change from this value right here up to this value. So that's going to be 0 to 4. And then the theta as an angle will go all the way around the circle. So that's going to be from 0 to 2 pi. Okay, so for r, it's going to go from 0 to 4, and for theta from 0 to 2 pi. Okay, so let's look at the next solid. So this one is a paraboloid, z equals x squared plus y squared, which is your bottom surface, and the top surface is z equals 9. Now, there's something else that you need to pay attention to, and that something else is that they say it's a first octant. So first octant means that all three coordinates, x, y, and z, are positive. That's going to put a restriction on your theta. It's not going to be all the way from 0 to 2 pi. It's just going to be from 0 to pi over 2. But the bottom surface is the paraboloid, x squared plus y squared. Now, you should know that whether it's polar or cylindrical, x squared plus y squared is r squared, because you can't keep the old coordinates. You're now in cylindrical coordinates. So your bottom surface is r squared, and top surface is 9. And then here is the idea here that you need to understand. So this is your first octant, right? All three coordinates are positive. So below is the paraboloid, above is that plane, z equals 9. But how do we know what is the radius of the circle? So if you think about where these two surfaces intersect, where is 9 and x squared plus y squared equal each other? So that's the same thing as saying r squared is equal 9, or r equals 3. So the radius of the circle, and then you can see this on the picture over here, that the radius of the circle is 3. So if you fix a theta, your r will go from 0 to 3, and theta would go from 0 to pi over 2. Okay, so let's go ahead and put that. So r is from 0 to 3, and this is 0 to pi over 2. Okay, so the last example is this is where you have a cone. So notice the difference between the paraboloid, which doesn't have a square root, and that's just z equals r squared. And this is a cone where it's just z equals r, right? So there's a difference whether it goes like a parabola or like a line. And on top, it's bounded by z equals 15. So the square root of x squared plus y squared, what is that? That's your bottom surface. So what is square root of r squared? Well, that's r, and the top is just 15. Now, we do have to figure out how does r and theta change, and let me show you that picture. So here you've got a cone, right? Z equals square root of x squared plus y squared, and then on the top is bounded by that z equals 15. So what is the circle here? What's the radius of the circle? How do we determine what is going to be the projection of this thing on the xy plane? Projection just means that z coordinate becomes 0. So everything is like splattered onto the xy plane. So you can see clearly here that this circle has radius of 15. But how did I know that? Well, you can set these equal each other. This is 15, and this is equal to just r, right? Because it's square root of r squared. So r equals 15 means that the radius of the circle is 15. So that means that r is going to go from 0 to 15 here, and theta will be all over, 0 to 2 pi.